All right, welcome back. So we're on to comparing fractions. This is another short section, so we'll just jump right into it. So last section we did some simplifying of some fractions, and this section we're going to do a little bit of reversing that, unsimplifying some fractions, and we'll see why. But let's go ahead and start with an easy problem. So which is greater, 3/5 or 4/5? You probably already know the answer to this, but if you think of a fifth just as like a baseball, like an object, you know, if you have 3 of something or if you have 4 of something, which one's bigger? Obviously the 4 of something. But so because we have 3 of 1/5, right? We have a 1/5 here, we have a 1/5 here, we have a 1/5 here, right? We have 3 of them. We have 3 1/5s. And over here we have 1/5, 1/5, 1/5, and 1/5. We have 4 of them. We have 4 1/5s. So of course this one is greater right here. Also we can see on a number line, if we have 0 and 1, and we split this up into 5 parts, so it's 1, 2, 3, 4, okay? Then 3/5 is 1, 2, 3 is right here. This is 3/5, and 4/5 would be right here. So we know that 4/5 is bigger than 3/5. That one's pretty easy. All right, let's go on to the next one. Okay, so for this one here, we have different denominators. Which one's greater, 3/5 or 7/10? So now we're getting a little bit harder, but still not too bad. So what fraction with the denominator of 10 is equal to 3/5? So we have 3/5, and we saw that in last section we can express the same fraction in different ways. Like 1/2 is the same thing as saying, let's say 4/8, for example, or the same thing as saying 2/4, or the same thing as saying 3/6. All those are equal to each other. They're all simplifiable down to 1/2. So we're going to do the same thing in the other direction for 3/5. So 3/5 would be the same thing as 6/10, right? All we have to do is multiply by 1. We can always multiply by 1, right? 2 over 2 is 1. So 3 times 2 and 5 times 2 gives us 6/10. All right, so now we can say which one's greater, 6/10 or 7/10? Well, we know the 7/10 is going to be greater than 6/10, which means 7/10 is greater than 3/5. Okay, which is greater, 5/7 or 8/11? So the last problem, we were able to make one denominator match the other denominator, but we can't do that for this one. So how do we do this? Well, we're going to have to find a common denominator. So what could we make the denominator so that they can both get there? Well, the easiest way to do this is, well, I wouldn't say always the easiest, but a surefire way that will always work is to multiply one denominator by the other. So 7 times 11 or 11 times 7 will give us the same denominator in both. Right? So we'll just do that. We can multiply 5/7 by 1 by 11 over 11, right? And then we can multiply 8/11 times 7 over 7. And we know that the denominator is going to be 7 times 11 here and 11 times 7 here. So they're going to be the same. So this one here will be 55 over 77. And over here we'll have 56 over 77. So we know that 56 is greater than 55, which means 8/11 is bigger. Okay, same thing for this one. So we have 5/6 times, we'll do 9 over 9, and the other one is 7/9 times 6 over 6. This will be equal to 5 times 9 is 45 over 54. 7 times 6 is 40, nope, that's not a 4, 42 over 54. And 45 is bigger, so 5/6 is bigger. Okay, so we could do the same thing. We could multiply by 5 over 5 and 7 over 7, but actually, in this case, we have the same numerator. So if you have the same numerator but different denominators, now you might already know from previous math courses that the smaller denominator is actually bigger. But let's think of why that's the case, first of all. So I always like to think of a very simple example just to remember this. So we have 0 and 1 on our number line. And let's say we have split into two, right? Two sections here. In the middle right here is going to be 1/2. But if we split it into 4, let's say, this is still 1/2, that's still right. But this here would be 1/4. So you can see that 1/4 has a larger denominator, but 1/2 is actually bigger. So the smaller denominator is actually bigger when you have the same numerator. So in this case, 2/5 is going to be larger than 2/7. If we were to show that on a number line, real quick, it's a pretty quick lesson, so we'll take some time to do this. So we have 0 and 1, and we split it into 7. So 1, 2, 3, 4. Let me spread that out a little bit. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7. All right, so 2/7 would be right here. 2/7. But if we split it only into 5, let's see if we can create pretty much the same number line here. So 0 is right here, and 1 is right here. And so let's go like 1, 2, 3, 4. So 1, 2, 3, 4, 5 sections. Now, and this is again 0, this is 1. So 2/5 is 1, 2/5 is right here. So not perfectly to scale, but I got the general idea where if you have less number of pieces that you break it up in, then each of those pieces is bigger. So the 2/5 is going to be bigger than the 2/7. All right, so which is greater, negative 17 over 14 or negative 41 over 35? All right, well, let's just get common denominators because we know that's what we need to do. So let's see. 14 and 35. Well, trying to think of an easy way to do this here. Okay, I guess we'll just do 17 over 14 times 35 over 35. Is there any easier way to do it? Well, so in this case, there's actually a common denominator that is not so large. And if you remember from a couple sections ago, finding the lowest common multiple, that's what we could do in this case. We can find the lowest common multiple, because really any common multiples will work to put in the denominator, but finding the lowest common multiple would be the lowest common denominator. So we could do that in this case. And in this case, if we multiply 14 by 5, we get to 70. And 35 times 2 would give us 70. So let's go ahead and do that. So we have negative 17 over 14. 14 times 5 over 5. And we have 41, negative 41 over 35 times 2 over 2. So you don't always have to multiply by the other denominator if you can find a common denominator that is easier. So 17 times 5 is 85. Don't forget our negative sign. Negative 85 over 70. And this is going to be negative 82 over 70. All right, so it looks like 85 is bigger than, oh wait, don't forget these negative signs. And you know that's something like negative 82. If we just ignore the fractions, negative 82 would be actually larger than negative 85. and be the same case for these fractions. So negative 82 is actually farther to the right on the number line than negative 85. So here, again, if we have 0 here and we have negative 1 and negative 2, negative 1 is actually larger than negative 2, right? So negative 82 is larger than negative 85, which means that negative 41 over 35 is larger. Okay, so yeah, so we just got to get common denominator, right? So 541 over 539 times 401 over 401. Is that the right way to do this? No, let's not do that. That would be a pain. Okay, so instead, let's think of it a different way. So the whole point of this problem here, this slide here, is to show you don't forget to take shortcuts and don't forget to think about what fractions actually are and what they mean. So how big is 541 over 539? Think about it. Well, we know 539 over 539, that would be 1, right? So 541 is a little bit, or 541 over 539 is a little bit over 1, right? Just a little bit over 1. How about 399 over 401? Well, we know that this is a little bit under 1 because 401 over 401 would be 1. So 399 must be a little bit less than 1, a little bit less than 1. So this is more than 1, this is less than 1, then we know that this is greater. And that's it for 4.6. So go ahead and do those 4.6 exercises, and we'll see you for the next one.